I'm going to tell you some of the ways the universe will end. Will end in your lifetime.
In that case, I take it back.
All right, so let me give you some scenarios that are on the docket.
Okay.
Okay. As you may know, we are currently expanding.
Yes.
All right.
That's right. Growth, damn it.
And as we expand, the universe gets thinner and thinner, less and less dense.
If you're not growing, you're dying.
Well, consider, how do you make a star? We have a gas cloud and it collapses
right.
to make a new object.
Right.
But if things continue to expand, then there's an interesting sequence of events. First, there are galaxies that have already used up all their gas.
Okay.
They have these elliptical shapes. We call them elliptical galaxies.
Oh.
They don't have any gas, but they have stars that will live 1 trillion years.
Wow.
After 1 trillion years, those stars start dimming out one by one. They will pluck out one by one trillions of years from now, because that's their life expectancy.
Okay.
They're burning their fuel very efficiently, very slowly and very efficiently. These are the dim red stars, of which there are many in every galaxy.
Right.
All right. But there's no gas in the elliptical galaxies. There's no fresh generation to be made. All right. In spiral galaxies such as ours, the Milky Way, we have stars that will also live 1 trillion years. They'll pluck out at around the same time these other stars do, but we have residual gas.
Right.
So we're making stars today.
Yes, stellar nurseries.
Yes.
Yep.
Yes, the JWST.
That's it.
It's all up in that.
Yeah.
So that will only continue until there's no gas left.
Right.
So for a spiral galaxy, it might go another 5 billion years, perhaps.
Oh, okay.
And when we run out of gas, that's the last generation of stars to get made. You're literally out of gas. Oh, by the way, in the distant future, as we continue to expand, galaxies will expand beyond the horizon that we have established from our location here. So what is that horizon? That's where they're moving away from you faster than the speed of light. So their light tries to reach you, but it can't. It can't.
Wow.
All the energy gets sucked out of it. And so every galaxy in the night sky will go beyond that horizon. Okay? With or without its stars, it'll go beyond the horizon. So if we look outside of our own galaxy, there'll be nothing there. As far as we know, our entire universe is just the stars, living or dead, in the Milky Way.
In the Milky Way. Oh, that's...
So our entire understanding of cosmology in a post-apocalyptic civilization in that very distant future will have no idea the universe had a beginning at all, because we know about the beginning by looking at other galaxies.
Right.
So a page in the history of the universe will have been removed, and they will not even know it. But wait, there's more. There's the matter of the black holes.
Okay.
Okay?
Interesting.
All right. So the black holes, the small black holes, actually will evaporate.
Okay.
Okay, using Hawking radiation. All right, so just outside the event horizon, there are these spontaneous particle pairs that are formed out of their gravitational energy field.
Right.
And one particle escapes, the other falls in, and that effectively subtracts mass from the black hole.
Okay.
So we will lose those black holes in 10 to the 30th years, something like that.
Okay.
And around then, our best hypotheses for the survival of the proton. Okay, we think the proton might decay. If the proton decays, that's it. The proton decay, we're thinking, also happens at around 10 to the 30th years.
Wow.
Last I checked. Okay. It could be up to maybe 10 to the 32 years,
right.
But that's around where, sure, 10 or who's counting, when we have factors of trillions and gazillions.
Right.
All right. That means the structure of all matter, which is, our foundation is on the nucleus composed of protons and neutrons. Right. But neutrons, free neutrons decay, but protons are the stablest particle we know, they're gone.
Right.
Okay.
Well, that's it.
But wait, there's the supermassive black holes in the centers of galaxies.
All right.
They take longer to evaporate.
That's true.
They'll still be there.
Right.
They don't just go away just because the universe expanded every other galaxy out of it and just because all the stars died. How about those? They take 10 to the 100 years to evaporate.
Wow.
You know what 10 to the 100 is? What number that is?
10 to the 100?
Yeah.
That's 1,000.
10 to the third power is 1,000.
Yes.
10 to the 100th power, that's a Google.
I did not know that.
So that's a lot of years.
That's beyond a lot.
Okay, that's a lot of years.
Yeah.
All right. So all matter is just scattered evenly into the vacuum of space, whatever's left of matter, and the universe dies. There's no more phenomenon to happen.
Okay.
You don't even have black holes evaporating.
Right. Everything's done.
And the temperatures have been dropping the entire time. Early on, it was very hot.
Right.
It was glowing hot.
Glowing hot.
Right now, it's cooled to 3 degrees absolute zero.
Right.
That's very cold,
Right.
but it got even colder.
Even colder.
To near absolute zero in the very distant future. Okay? So in that scenario, the universe will not die with a bang, but with a whimper. And not in fire, but in ice.
Oh.
So for a while, people call that the heat death of the universe. But these are thermodynamicists saying that because to them, there's no such thing as cold.
Right.
There's only heat or the absence of heat.
That's
okay?
it. Right.
So the heat
now
death,
all the heat is gone.
So they call it
the heat death.
But that's so misleading.
Exactly.
So I just prefer to call it the big freeze. We know what's driving that.
Okay.
What we do know about it tells us that it is unrelenting. So it's not just an expansion that'll continue forever.
Right.
It's an expansion that will accelerate.
Forever.
Accelerate.
Wow. That's
forever.
crazy.
Because it is a property in the vacuum of space. That's what we call dark energy. So the more the universe expands, the more vacuum you have.
Right.
And the weaker gravity becomes because all the matter is getting thinned out. It's
Spread
getting
out.
thinned
Spread
out.
out. Yeah.
Okay?
Like butter on hot toast.
All right, so you can do the math on this. So first, yes, all the galaxies will accelerate beyond your horizon. That'll happen. We got that in the first one, okay? But here's what the difference is. If that acceleration goes unchecked,
Right.
then it'll start ripping apart things that would otherwise retain their integrity from their gravity.
Right.
So first, they're galaxy clusters that even in an expanding universe, they'll want to stay together. With the accelerating expansion,
They'll be
it'll
pulled
start
no matter what.
pulling them out, pulling them away. Then, once it's destroyed the galaxy cluster, now it's going to start working on the galaxies,
Right.
which are tightly bound systems of stars. As the universe continues to expand, the strength of that expansion will become greater than the binding gravity of the systems themselves.
Ooh.
So it'll start ripping apart
galaxies.
Okay.
Damn.
Then you don't have galaxy clusters. You don't have galaxies. Now you just have stars, and their planets. It'll start plucking the planets away from the stars.
Home wrecker. Just a home wrecker
Then
is what you are.
It'll start ripping apart
The star
the
itself.
stars and the planets themselves. These forces are strong.
Yeah.
Okay? So it'll start becoming stronger than the electromagnetic forces that holds matter together.
Damn.
Until next time, as always, keep looking up.